All right, Sectional Illuminate Association of American Railroads Operation Maintenance Department of the Engineering Mechanical Division Electrical Manual Standards Recommended in Practice. Sectional 5 Illumination 1966. Table of Contents, Chapter 1, Illumination, Part 1 and 2, General Reflection Factors, Glossary, Illumination Terms, Chapter 2, Eliminating the Fixture Properties, Outdoor Air Lighting, Flooding Lighting, Railroad Yards, Indoor Air Lighting, Chapter 3, Lighting of the Passenger Carrying Roller Stock, General Mainline Coach Lighting, Suburban and Short Haul Coaching Lighting, Dining Area Lighting, Kitchen Pantry, Buffet and Servicing Area Lighting, Sleeping Car Lighting, and Lounge Observation Car Lighting, with Chapter 4, Factors Affecting Efficiency, Part 1, Maintenance, Chapter 5, Lamps, Part 1, Recommended Lamps for Locomotive Passenger Cars, Electrical Lamp Characteristics, Section of Fluorescent Lamps, Chapter 6, Evaluation Measures and Tests, General Measurement, Rolling Stock, and Fixed Properties. Chapter 1, Illumination, Part 1, Generally. Lights may be defined as the form of the radiated engine capable of producing sensation of the sight. Visual energy exceeding a small portion of the electromagnetic travel through the space and form of electronic magnetic waves, although the forms of radiated energy are transmitted with the same rate of the speed of the vacuum of 186,300 miles per second. However, each of the form different for the wavelength frequency. The human eye can be considered as a receiver tuned and respond only to the energy with the limit of the visible spectrum narrow band of the wavelengths between 300 angstroms and 7,600 angstroms. The angstroms is the wavelength until unit equal to the 1/10 of a million millimeter, approximately 4 billionth of an inch. Light may be produced in many ways, generally listed under the heading of the incandescent luminescence of the candle flame of the filament lamp, or the extended with the incandescent with the fluorescent lamp. The familiar example, the lumen eye, a function of the ability to transfer the lumen light stimulus. The impulse may be transmitted through the nerve of the brain with an analyzed reaction initiated with a distorted perception of the contrast of color, shape, and depth, action, direction. Therefore, much of the human thought action depend on the consistent response of the eye to light. It takes time to see. The speed of vision depends on size, contrast, illumination of the task. If it's given the task, then the speed of seeing depends on the brightness of the task. Since the brightness of the surface rather than illumination asserts foot candles is utilized in seeing. It is important to note that the foot candle level recommended for seeing the high reflectant surface may be totally inadequate with proper seeing of the darkness. Low reflectant surface is expressed in terms of foot lambda, the brightness, and any non-spectacular form surface of an incandescent light times the reflectant factor. Under the same illusion of the brightness of the white paper, the reflectant factor of 0.8, the 4 times the cast iron reflecting factor of 0.2. Should be noted that during the reduction of the pupil side of the eye, which accompanies the advanced age, higher brightness are required of the equivalent effect of the eyes in older observers. At age 60, the age observer requires twice the objective brightness of the equivalent seeing the 20-year-old observer. The handicapped person with visual effects are so decreases illumination is increased. Visual sensation caused by brightening relationship with the field of view may interfere with view of the seeing the task. They interfere with the brightness of the also called glare. Glare source may also be annoying and uncomfortable, completely preventing with the proper seeing. Disability glare may be present whenever the source of the high brightness then the task is superimposed on the view of the discomfort given. The may exhibit the excessive brightness source within the normal viewing angle that apply to the both directly related source of the glare. Glare and glare resources may often become more important in eliminating the factor of lighting installation should be thoroughly analyzed with the lighting installation planner. Any illumination should be provided with sufficient quantity to quality control, seeing the task to minimize the fatigue and counter with visual efforts. Industrial adequate lighting must justify in the dollar cent terms of a warning consideration. Many studies have conducted to provide with good lighting, increase the production, reducing time seeing the production of work, whether it is in the office or shop. Reduction of fatigue improvement, the more aware of all the workers as result in direct gains in output. Reduction against accidents, another important factor gained with good lighting in relations with public good illumination plays a most important rule. For example, if you are poor economically, neglect the adequate timing of the lighting of stairways when one accident might be caused many hundreds of times the cost of the good lighting. The following section manually accordingly concerned with the recommendation guide with the economical feeding lighting levels. In some of the cases, methods lighting certain properties peculiar with railroad industry lighting planner. However, there should also evaluate the particular seeing test as with this, which is confronted with the term the basic principles of the most modern economic system available, realizing the newest development may rapidly outdate any manual. Chapter 2, Illumination, Part 2, Reflection Factors. Reflection factors are usually light calculations should be taken into account with considering visual comfort and utilization of light and general atmosphere in the room and interior of the ground is maintained within more lightning field. The higher lighting levels then emphasize important to select the interior finishes relatively high for reference in order to ensure comfortable brightness ratio. The in general brightness ratio between the task and the ground is approximately 3 to 1, one less to desired or less to be desired. Reflection factor reflections is the ratio of light reflected with the surface of the incident light of the surface. The conveniency of the method determining the reflection factor. Use the foot handle meter holding it against the surface with the photocell facing perpendicularly away from the surface to measure incident light. The meter is reversed with the photocell facing the surface moved about 10 inches away from the surface. The measure of light is reflected from the surface. The second reading is divided in the first time determine the reflection factor, which is always less than the unity. Reflection factor surface of the color within the light and the surface of the light. In the case of light covered colored walls and ceilings are most sufficiently dark colors convenient to light distributing uniformly. Increase the wall reflectiveness factor to 9 and changing color with the dark green with the reflecting factor of 0.8 with light pastel greens. The reflecting factor of 0.72 may result in the tripling illumination in the room without changing the lights, but this will depending on the ratio, length, width of the height, and most in the common case of the effect of being regular large rooms. Tests have determined when a color degrades surface equals the reflection equally illuminated light directed to the source, they will be equal to bright. However, the considered portion of light reaching the work surface to undergo the several reflections such as walls, floors, and ceilings is usually the case with indirect, semi-indirect lighting systems. Greatly illumination will be obtained with the reflecting surfaces colored whether they are grades and assume the reflection factors. The great number of the interior of reflection of the greater advantage of the color surface over the gray is, for example, the reflection for the yellow surface, 80% of the original light will be present and is compared with the 10% or medium gray. The color chosen from the interior involved good taste, psychology, physiology, and other factors. However, the standpoint of the interior light should be relatively high roughness, reflectance, non-spectorial, not glossy finish. Most of the emotionally responsive for the surrounding the color is one of the factors determining what the surroundings are like. The colors of the red end of the spectrum are physiologically warming and stimulating, while those of the blue create the impression of coolness, while the warm, cooled surface advances toward the observed. Hence, the room finished with warm colors seems smaller in the real, and conveys impression of the conciseness and intimacy. Conversely, cool colors tend to recede, then they move and may be used to increase the apparent size of the room, creating an impersonal atmosphere. Surface appears colored only because of the all selective reflective colors and incandescent light. Some of the different light sources produce light different. The spectrum composition understand with the warmer color surface, the more efficient reflective light in incandescent lamps from cool white and fluorescent blue-green surface alternately with a higher reflectancy colored white fluorescency than incandescent warm white fluorescency. Due to multiple shade tints and colors of it is not practical here to show all reflection factors. However, the following tabulation list of average values generally the recognized colors, white light reflectance values suggested with office industrial paint plants are listed in the following: ceilings, walls, floors, trims, furniture, machines, deck and bench tops. Section 5, Illumination, Part 3, Glossary of Illumination Terms. The following term, the definition, reproduced with the Illumination Engineering Society Handbook of other sources. For the more detailed study, refer to the last Illumination Engineering Society Handbook. The candle power is the unit of measurement of the luminous intensity expressed in candles, efficiency, utilization, illumination, installation, total flux received with the reflection, reference of the plane divided by the total flux emitted with the lamps and illuminating it. When not otherwise specified with the plan with the reference to assume the horizontal plane 30 inches above the floor. Efficiency, the ratio of the total luminous flux to the total power input expressed with the lumens per watt. Electrical fluorescent amp light consistent with the glass bulb encasing the filament extra electrically maintained with the incandescent, commonly called with the incandescent lamp, filament lamp, incandescent filament lamp, and electrical light and light bulb. Electrical discharge lamp, a lamp which is light is produced by the passage of electricity through a metallic vapor causes the mercury, sun, sodium, neon, argon enclosed in the tube of the tube or bubble, sometimes called the vapor lamp. This includes mercury fluorescent discharge lamps. Art your foot candle light is the use of measured illumination on the surface of the foot of the square in a 1 foot area. The use uniformly distributed and flexible one aluminum. It equals 1 aluminum per square foot. Foot candle equals aluminum's areas in square foot. Foot lambert. The foot lambert is a unit of brightness equal to 1 pi candle per square foot. The uniform pi photometric brightness and surface and the source emitting the reflecting at the rate of 1 luminol per square foot. Illumination. Illumination intensity. Aluminum flux up on surface needs the foot candle. The inverse square law states illumination surface varies depends directly on candlelight sources inversely with the square for the difference between the source of the surface of foot candles and candle powers over the distance squared lamp or cubed. Lamp of the light surface aluminum. Aluminum is a unit of luminous flux exactly the equal of the flux illuminated with the unit sold angle or 1 steradian of the uniform point surface of the 1 candle. Aluminum source of 4 pi times means of cylindrical candle power. A luminaire is a complete lighting device including the lamp with the global refractor housing each of the support of the integral within the housing. The term luminaire is used to designate the completely equipped lighting fixture. Luminous stat intensity signal, a solid angular luminous flux density of the direction in the question equals the quote, and with the flux illuminated surface by the same solid angle subtended with the element of view in the source. Luminant flux, the quantitative expression of the visible radiant energy emitted with light surface. Mechanical means cylindrical candle power. The lamp with the average candle power with the lamp in all directions in space equals the total luminance of the lamp divided by 4 pi. Brightness is the luminous intensity of any surface given the direction per the unit projected area of the surface of view for that direction. It may be expressed in terms of luminous speed, emitted, reflected from a perfectly diffusing surface. Reflection factor, the ratio quality of the lighted reflected by the surface quantity incandescent light. The reflection factor equals reflected light divided by incandescent light. The transmission factor, transmitted ratio quantity of the transmitted material incandescent light. The transmitted factor is the transmitted light divided by incandescent light. Chapter 2, Lighting and Fixed Properties in Part 1, Outdoor Area and Lighting and Flooding Lights in Railroad Yards.